Alright guys, so I'm just here to discuss my assessment topic of the hyperboloid revolution. So I've phrased and designed this question very specifically by giving them very limited information, because I want to challenge students' knowledge of the key principles and being able to know that you can take widths from plan, bring them into elevation, that you can mirror different objects over, but all these kind of steps require a lot of understanding of how the shapes are formed and like why they're formed.
And how are you going to help them understand key principles, and like how are you going to make the key principles relatable to this specific question?
So with this specific question, I've just made a little model just with some sponges and some skewers. So as we can see here, this actually looks like the real life example, but we can also get a lot from this model purely because we know that the two closer points on the inside here are the vertexes, vertex 1 and vertex 2. And we know that these are rotated around an axis. So can you see any intersectionality with this question here?
Yeah, you have just the V1 given in the question there.
Exactly. So if we look at the elevation looking straight in at this, we can see that we have our vertex 1 and vertex 2. So that's how I'm going to try and use real life examples to try and stimulate pupils' interests.
Yeah, just using the model there it's a good way of kind of helping the students understand the key principles needed to even start the question.
Yeah, good. Exactly.
Yeah, you have the model, but like what motivation, what value will the students get out of a question like this?
So the values and motivation they'll get out of this is they'll gain an appreciation for the actual, it's not just 2D drawing, it's an actual, it's used in structures, it's used in for bridges, it's used for, this is a church in Brasilia, really famous church, so it's used in a lot of kind of real life practical applications because it's a very strong structure. And just moving on to the next part of this, it's I've given them a scale and I've given all my measurements in meters. So the reason why I've done this is I want to try and challenge the students in the question, but also with their numeracy skills. I want to try and build them up. So the scale is 1 to 500. So they're going to have to go through every single dimension that's been given to them. They're going to have to scale it down to in millimeters and then be able to actually draw the question. So I think through the use of the real life examples, challenging them with their numeracy skills, challenging them with the key principles from their previous knowledge and their new knowledge that they've actually gained, I think that students would be able to do this question, but not easily. Some students will be, some students may not be. It's just it needs to show a clear understanding of kind of what's going on.
Why do you think bringing the numeracy skills into a DCG question like this is good for students? Like what would they get out of that?
Well, with STEM, it links very nicely in with science, technology, engineering and maths.
Yeah.
So I don't want all those different subjects to be, single subjects. I'd like to have a bit of an intersectionality between them all and kind of merge it all together and challenge them that way.
Yeah, that's good.